Okay, welcome again our viewers as we embark on our revision again. Welcome to our class tonight. And today we are dealing with trigonometric ratio. Let us feed our mind with the right thing, especially this period that we have the longest holiday ever. So let us learn to feed our mind with the right thing. Go to your study room, go to your table room, go to your kitchen, everywhere you are. Just make sure you are feeding your mind with the right thing. Stay closer to the books. Even when you are not reading the books, just allow yourself to be closer to the books to ensure that your mind is feeding on the right thing. Because mind is like body, it grows by what it feeds. So just feed on the proper diet of the mind and you'll be okay. So and again, you remember we've been saying again, repetition creates retention. Revise, do it again until it gets into our minds. And as we, by the time we shall be opening schools, at least we shall be in a better position. We shall be, our mind shall be in a better position even to continue with our learning. So the holiday is big. Let us use it maximally, optimally for our own good. Today we are going to do some few examples of trigonometric ratio. Remember, we are revising. This is a chapter in Form 3. We shall be able to tackle some few examples on the same, and God will praise us. So one of the first example is given sin 90 minus a is half. Find without using trigonometric tables. Without using trigonometrical tables, the value of cos A. The value of cos A. We are told that given sin 90 minus A is equals to half. Find without using trigonometric tables the value of cos A. This one we shall be required to use trigonometric triangles, and we shall use the a trigonometric angle, which is a right angle triangle, which is isosceles triangle. And in this case, this is an angle at 90 degrees. If this is our A, then this one is our 90 minus A. If this is angle A, this is angle 90 minus A. Therefore, using this one, what is sin A? What is sin A? Remember the rule that we've used previously. That is SOHCAHTOA, which means sin theta is equals to opposite over hypotenuse. Sin theta is equals to opposite over hypotenuse. Therefore, sin A is equal to opposite over hypotenuse. Therefore, sin A is equals to opposite over hypotenuse. Is equals to opposite of hypotenuse. Therefore, but we are given sin 90 minus A is equals to a half. So what is sin 90 minus A? Is also again opposite over hypotenuse. Sin 90 minus A is equals opposite over hypotenuse. But remember, this opposite for sin 90 minus A is different for opposite of sin A. Sin A, the opposite is this side, but for sin 90 minus A, the opposite is the other side. But for sin 90 minus A, we are given is equals to a half. What does that mean? It means that this one is 1 and the hypotenuse is 2. This is 1, the hypotenuse is 2. So that we can have opposite over hypotenuse. Then the question is find cos A. We are going to find cos A. And the cos A, remember, we should find cos A by finding opposite over adjacent, because, opposite of hypotenuse, because of cos theta is equal to adjacent of hypotenuse. Adjacent of hypotenuse. So if this one is 1, this one is 2. What is the value of opposite? What is the value of this height, which is opposite? Remember, this is a right angle triangle. Therefore, we use the rule of Pythagoras theorem, whereby we say hypotenuse squared is equal to adjacent squared plus height or opposite squared. In our case, the hypotenuse squared is 2 squared is equals to 1 squared plus height squared. This one will give us 4 equals to 1 plus height squared. And our height squared will be equal to 4. We take 1 the other side, so it will be 4 minus 1. And our height squared is equals to 3. We want our height. Therefore, we find the square root and the square root. And our height will be square root of 3. Will be square root of 3. Therefore, adding this one, which is this height now here, we can be able to find cos A. Because cos A, remember this is our A, is equals to adjacent over hypotenuse. Yeah, we can find just both cos A and the cos, you can add this one to our equation, cos A and the cos 90 minus A. You can add that one to our equation so that we can be able to tackle both of them. Now, cos A, our cos A here will be equal to adjacent of hypotenuse. Therefore, cos A will be equal to 1, which is adjacent, over hypotenuse, which is 1 over 2. Then what is cos 90 minus A? This is this one. It will be equal to adjacent over hypotenuse, which is 2. And our adjacent we found from our calculation is equals to square root of 3 divided by 2. This is our cos 90 minus A. Cos 90 minus A. Yeah, that's our first example. It is not hard. You can just do it once and once. You can do it again and again. And as you continue doing it, it becomes more simpler. Remember, practice makes perfect. So mathematics is about to practice. It is about to practice. You practice until it gets into the mind. Then we do another example. That is find the value of theta given that I have seen theta is equals to 0.35 for angles ranging from theta 0 degrees, to 360 degrees. We are told to find the value of theta given that I have seen theta is equals to 0.35 for angles ranging between 0 and 360 degrees. This one we needed to use another aspect of trigonometric ratio, that is unit circle. I know most of us, as we were doing the coursework, we came across that tool, that is unit circle. Yeah, most of us we we used to call it arcs, whereby at this quadrant all angles are positive, but at this quadrant only cosine is positive, at this quadrant only tangent is positive, and at this quadrant only sine is positive. Now in our case here, because we already given a half, sin theta is equals to 0.35. We need to find the theta so that we can find more angles that are ranging from 0 to 360 degrees. And in our case, when we are given this one, we want the value of theta. So how do we solve for the value of theta here? We multiply here by 2. We multiply the other side by 2. This one will give us sin theta is equals to 0.70 or 0.7, simply 0.7. Sin theta is equal to 0.7. But we want sin. What do we do to remove this sin? We divide here, we want theta. So what do we do to remain with theta? We divide by sin. And the other side we divide by sin. This one will give us theta is equals to this sin. This is where we usually get sin inverse. This is where we get sin inverse, because when we get 1 over 2, it's the same as 2 power negative 1, which is inverse of a half. So this is the same as 2. So we are sin inverse is just the inverse of sin. The inverse of sin. So in our case here, we shall have, this is the same as sin inverse 0.7. If you use your calculator, you find that theta, if you find sin inverse 0.7, you get theta is equals to 400 and not 400 but 44.4 degrees. 44.4 degrees. Therefore, our theta, the first value of theta is equals to 44.4 degrees. But remember, we are finding a range of angles that are ranging from 0 to 360 degrees. Using our unit circle, if this is the first angle, we can find another angle. Because remember we said all angles at this point are positive. So if that is the first angle, which is 44, which is a acute angle, which is 44.4 degrees, we need to find, remember at the range, there are no negative angles. So we need positive angles. And remember, in our quadrant, only in the first quadrant, angles are positive. All angles are positive. And in this case, our sin theta is positive, which is 44.4. So we need to find another angle that is positive. And another angle that is positive should be found on the second quadrant. It should be found at this quadrant where we have sin. Because at this quadrant is this where we have sin as positive. Any other place except this one and this one, the sin will be negative. The angle will be negative. The angle will be negative. So in this case, how do we find the second angle from our second quadrant? Remember, this is the second quadrant. Therefore, we do 180 degrees minus, remember this angle, there is another such angle here. So it will be 180 degrees minus 44.4 degrees. 44.4 degrees. And this one will give us 133.6 degrees. It will give us 133.6 degrees. This is our second angle. This is our second angle. That is enough for today. And remember, we are starting a week. We just need a little bit of refreshment. That's what we can have. And remember, we said again, if you have a problem, remember we've tackled indices, we've tackled the equation of straight line. Now we are in trigonometry. This is just an introduction. We've done some few examples on the same. two examples I mean. So if you have any problem on equation of straight line, on indices, on trigonometry, or any other topic in mathematics from Form 1 to Form 4, we have 65 topics in mathematics from Form 1 to Form 4. Just raise your question, raise your concern, we help one another, because remember we said this is an ecosystem, we need to help one another, especially at this period. And I also remind you again, just make sure you are filling your mind with the right thing. Just remain close to your books, be closer to your books, make your books your friends, and any other person that will provide relevant information to your mind. Just make sure you are closer to them each and every time, and by the time we are opening schools, that we shall be in a position to do well even in our exams as we prepare for our exams. So just have a good night, and remember to wear your mask, remember to sanitize, wash your hands, keep social distance, and make sure you are taking caution. Remember, the government reminded us that this thing is not for the government, is not for your neighbor or anyone else. It's about you. So as God takes care and aligning the world, aligning us to another map or another pattern, just make sure you are taking care of yourself, and God shall bless us. Shalom, shalom, shalom.